Okay, so this video is about scalar and vector resolutes of a vector. So by the end of this video, hopefully you will be able to resolve a vector into its two components, one parallel to and one perpendicular to another vector. What do I mean by that? As we're any vector is the sum of component vectors. As long as they start and finish at the same points, then they're the same. So in this particular case, there's one component, there's another component. So this component, C plus D equals A. Now we're really interested in these two components which are at right angles to each other. C we call the vector resolute. This is the resolute of A in the direction of another vector, which we're going to call B, and this is the resolute. This is also a resolute of A. So if I have another vector, which I'm going to call B, then C is the resolute of A, which is parallel to B, and this D is the resolute of A, which is perpendicular to B. Let's see how that works in real life. Here's a scalar projection of A in the direction of B. So we've got A, we've got B. The scalar projection, if I just drop down my right angle there, the scalar projection is this distance here. The scalar projection of A, so let's call that O, and that's N. So that distance there, the magnitude of that distance, is the scalar projection of A onto B. How do we work that out? Well, we use our dot product. It's A dot B hat. B hat being a unit vector in the B direction, and we're looking at A dot B hat. That gives us the magnitude of vector that has the magnitude of ON in the B direction. Now we're looking for a vector resolute in that same direction. Well, we've already said that that distance, the magnitude there from O to N, we've already said that the magnitude of that was A dot B hat, the unit vector in the B direction. Now we're just multiplying that scalar number by a unit vector in the B direction. And the last thing that we're doing today is vector resolute of A perpendicular to B. By perpendicular, here's A, here's B, we're talking, there's N, M, so I'm looking at that vector, which is going that way. So MN, or N starting at M, N and going to M, that's A minus the unit vector, A dot B hat times B hat. Let's see how that works in real life. Let's apply some of these formulas to a particular question. Find the vector resolute of 3i minus 2j plus k in the direction of. So start off by giving these A equals 3I minus 2j plus k. B equals I plus 2j minus k. What we need to do is find B hat. So let's find B hat. We need the magnitude of B, which is going to be 1 squared plus 2 squared plus 1 squared. So that's 4, 5, 6, square root of 6. So the magnitude of B is 6. So B hat equals 1 over root 6 of I plus 2j minus k. So now we're ready to do our vector resolute. Which equals A dot B hat all times B hat. So let's do A dot B hat is 3I plus 2j, sorry, that's a minus 2j plus k, and we're going to dot 1 on root 6 of I plus 2j minus k. Now for convenience I'm going to keep, I'll have the root 6 in, so we want 3 times 1 on root 6 becomes 3 on root 6. 2 minus 2 times 2 makes minus 4 on root 6, and 1 times minus 1 on root 6 becomes minus 1 on root 6. So 3 minus 4 minus 1 gives me minus 2 on root 6. Now that's our A dot B hat. And then we want to times all of that by B hat, which is 1 on root 6 I plus 2j minus k. So all of that, there's our B hat in there, and so this becomes times 1 on root 6 I plus 2j minus k. And what do you notice? That becomes minus 2 on 6 outside of I plus 2j minus k, which becomes minus 1/3 I plus 2j minus k. So there is a vector which has a magnitude. It is the vector resolute of A in the direction of B. Okay, bit of mucking around, but now we want the vector resolute. Part B of this is to find the vector resolute perpendicular. So we're going to use our answer. It's the same vector, so we're going to use our answer. We're going to go A minus A dot B hat times B hat. Now we already know what A is. A was our 3I minus 2j plus k. And we're subtracting our previous answer, which was 1/3 minus 1/3, minus 1/3 of I plus 2j minus k. So the minus and minus makes a plus. So let's try again. 3I minus 2j plus k plus 1/3 I plus 2j minus k. Let's work all that out. 3 plus 1/3. We'll have to put that 3 3s are 9, so 9 plus 1 makes 10 thirds I. 2 is 6, minus 6 plus 2 makes minus 4 thirds j, and plus 3 minus 1 makes 2/3 k, which I'll take the 1/3 out the front just to pretty it up a little bit. 10i minus 4j plus 2k. And there is our vector resolute perpendicular, vector resolute of A perpendicular to B. Okay, this has been a long video. I think I'm going to stop there.